Welcome to the deep dive. Today, we're tackling something really cutting edge. How scientists are trying to directly test our biggest ideas about consciousness.
Yeah, it's where philosophy meets neuroscience, head on.
Exactly. And our mission, really, is to figure out how we can make sense of the results coming out of these big experimental showdowns. We'll use the perspective of a philosopher of science, Imre Lakatos.
He offers a really useful lens for this.
Forget the dry theory. We want to get into the surprising ways science actually moves forward in this tricky area.
And we've got some good stuff to draw on. A recent paper in Neuroscience of Consciousness really digs into this Lakatos angle.
Okay.
Plus news reports on the experiments themselves from the Cogitate Consortium.
Yeah.
And we'll touch on the theories they're actually testing, of course.
Right, the Cogitate Consortium. Let's start there. What are they doing, and why is it considered such a big step for consciousness research?
Well, the big shift is towards these things called adversarial collaborations.
Adversarial. Sounds intense.
It kind of is. Instead of just, arguing in papers, theorists with opposing views actually team up.
To design experiments together.
Exactly. They design experiments where their theories make different, directly testable predictions. Cogitate is a major player here.
And goal is?
The goal is to use that hard empirical data, the experimental results, to, either force theories to get better, refine them, or maybe even show that some just don't hold up.
So it's like putting theories in the ring together. And the main fighters usually seem to be integrated information theory, IIT, and Global Neuronal Workspace Theory, GNWT.
That's right. Those are the two heavyweights in many of these recent tests.
Okay, for anyone listening who isn't immersed in this stuff daily, can we do the super quick version? What's the core idea of IoT?
Sure. IIT basically says consciousness is about integrated information. It's a property of how much a system's parts influence each other, how much cause-effect power it has internally. They measure this with a value called phi. And interestingly, IIT suggests consciousness isn't necessarily biological. Anything complex enough, information-wise, could be conscious.
Okay, provocative. And GNWT, the Global Neuronal Workspace.
That's a different picture. GNWT proposes that consciousness happens when information gets sort of broadcast across the brain.
Broadcast.
Yeah, made globally available to many different processing areas, like a spotlight on a mental stage, making information accessible for report, reasoning, memory.
So information we aren't aware of can still affect us, but consciousness is when it hits that global workspace.
Pretty much, yeah. Unconscious processing is still doing a lot, but the conscious part is that broadcast state.
Definitely different takes. And I recall reading there's serious money behind getting these theories into the lab.
Oh, yeah. There was that big $20 million project, Singularity Hub reported on it, specifically funding these head-to-head experimental tests.
20 million. Wow.
It shows how serious the field is about moving past just talk and getting actual evidence.
So with all this effort on experiments, is the hope still for that one killer experiment, what was it called? Experimentum Crucis.
Yeah, the decisive experiment. That was maybe the initial, slightly naive hope. Experimental eliminativism, find the one experiment that proves theory A and kills theory B and C.
But it's not working out quite like that.
Not really. What the Cogitate folks and others are finding is that theorists are, adaptable.
They don't just give up when the results don't fit perfectly?
Exactly. They tend to adjust things, tweak auxiliary assumptions, refine the edges of their theory rather than just ditching it.
Which kind of makes sense, doesn't it? It's hard to abandon a whole framework. This sounds like where that idea of a severe test comes in, Deborah Mayo's concept.
Right. Mayo's idea of a severe test is pretty demanding. It basically asks, if this theory was wrong, how likely is it that we'd still get this experimental result?
So a test is only severe if the result would be really surprising, really unlikely if the theory was false.
Precisely. And the first Cogitate experiment, the one looking at whether consciousness needs the front of the brain, the prefrontal cortex, or just the back.
Yeah, IIT pointing more to the back, GNWT needing the front too.
Right. They found results that lean towards the posterior, the back being key. But the problem is, from a severe test perspective, other theories besides GNWT also predict frontal involvement for some things. And other theories besides IIT might also say the posterior cortex is enough for some types of consciousness. So finding posterior activity doesn't strictly rule out all the alternatives in a way that Mayo's severity criterion demands. The result wasn't uniquely tied only to IIT being true and incredibly unlikely otherwise.
So no clear knockout,
Yeah.
which brings us back to Lakatos. His philosophy offers a different way to look at this whole process, right? Not just about single experiments.
Exactly. Lakatos talk about research programs, not just isolated theories, but broader scientific traditions.
Okay, research programs.
Yeah, he saw them as having a hardcore, the fundamental assumptions that define the program. The bits adherents won't easily give up.
The core beliefs.
Right. And around that core is a protective belt of auxiliary hypotheses, secondary ideas, methodological assumptions.
Stuff that's more flexible.
Much more flexible. When an experiment gives tricky results, researchers usually tweak things in the protective belt first. They adjust assumptions, reinterpret data, maybe refine the experimental setup itself, all to protect the hardcore.
So it's less about instant falsification and more about how these whole programs evolve over time.
Exactly. For Lakatos, progress comes from how these programs respond to challenges, whether they can adapt, accommodate new findings, and crucially, whether they keep generating new, testable predictions. That's the key.
That feels much closer to what seems to be happening with IIT and GNWT after the Cogitate results. Okay, so the paper uses Lakatos to suggest 3 criteria for judging these theories. First one, prediction versus accommodation. Why is prediction so important for Lakatos?
Well, Lakatos, like Popper before him, really valued predictive power. A theory gets more points, you could say, if it predicts something novel, something unexpected, rather than just explaining facts we already knew when the theory was made.
It's about looking forward, not just backward.
Right. A research program that consistently makes successful novel predictions is seen as progressive, but novel is a bit tricky.
It doesn't just mean predicting something nobody has ever seen before.
Not necessarily. Lakatos highlighted something called use-novelty.
Use-novelty, okay.
A fact has use-novelty for a theory if that fact wasn't used when building the theory. The classic example is Einstein and Mercury's orbit.
Right. The orbit's weirdness was known, but Einstein's theory wasn't designed for it, yet it explained it perfectly.
Exactly. That was a huge win for general relativity because the explanation emerged naturally from the theory. It wasn't baked in. That's use-novelty.
So how does use-novelty play out in consciousness research? The paper mentioned Sperling's experiments.
Yeah, the partial report stuff. Sperling showed way back that we seem to see more momentarily than we can actually report back.
Okay.
Now, IIT wasn't developed specifically to explain that, but proponents argue IIT provides a natural explanation for this gap between the richness of experience and our limited report capacity, maybe relating to levels of phi. So if that holds, it counts as a use-novel success for IIT.
I see. But there's a complication, isn't there?
Yes, a big one. The paper points out that a finding that seems like a use-novel prediction for theory A might also be explainable by theory B, even if theory B wasn't the one being directly tested.
So theory B could also claim it as use-novel evidence, potentially.
Potentially, yeah. The example given involves brain complexity measures, often linked to IIT. Finding correlations between complexity and consciousness states looks like a win for IIT. But then researchers like George Masur came along and argued that actually GNWT can also explain those complexity findings quite readily within its framework.
So the finding isn't uniquely tied to IIT after all.
Exactly. It shows we need to be careful. A result might support theory A, but if theory B or C can also accommodate it without too much trouble, its confirmatory power for theory A is lessened.
Right. That makes sense. Okay, let's move to the second Lakatosian criterion,
Yes.
structural relevance. What's this about?
This one is about digging into the structure of the theory itself. Remember the hardcore and the protective belt.
Yeah.
Structural relevance asks, how close is the prediction being tested to the theory's hardcore? Is it testing something fundamental or something out on the periphery in that protective belt?
Okay, so not all predictions carry the same weight.
Not at all. Some critics pointed out, for example, that the first Cogitate experiment didn't really test the deep mathematical machinery of IIT, the actual calculation of phi. And similarly, maybe it didn't directly probe the core broadcasting mechanism of GNWT, but rather predictions derived from those core ideas via several steps.
So if you're only testing predictions from the squishy outer layers, the protective belt, then even if the prediction fails, it doesn't necessarily damage the core theory much.
That's the idea. The theory can just adjust those peripheral assumptions. The closer a prediction is tied to the hard core, the more significant the experimental result, whether confirming or disconfirming.
Can you give an example?
The paper uses attention. If you have a theory where attention is absolutely fundamental to consciousness, part of its hardcore, then experiments probing that link are structurally very relevant.
Right.
But for a theory like IIT, where attention is maybe seen as modulating consciousness but not identical to it, the link is less central. If an experiment about attention gives surprising results, IIT might only need to adjust some auxiliary assumptions about how attention relates to integrated information without threatening the core phi concept itself.
Yeah.
Structural relevance forces us to ask, how much does this specific test really tell us about the fundamental claims?
Got it. It's about the prediction's place within the theory's own architecture. Okay, third criterion, boldness. This sounds exciting.
It is. This draws heavily on Karl Popper. Bold predictions are risky predictions.
Risky.
They go against the grain, against established background knowledge, or the predictions of competing theories. A bold prediction is one that seems unlikely to be true unless the specific theory making it is actually correct.
So it really sticks its neck out.
Exactly. If a bold prediction is confirmed, it provides strong support precisely because it was so unlikely otherwise. If it fails, it's a significant blow. Boldness is also linked to precision, clearly stating what outcomes would falsify the prediction.
And the paper gives IIT's idea about inactive neurons as an example of boldness.
Yes, that's a great one. The claim that neurons which aren't firing can still be part of the substrate of consciousness because of the potential causal connections they represent, that's pretty counterintuitive from a standard neuroscience perspective.
Definitely different.
It's a unique prediction stemming from IIT's core logic. Tononi and Koch themselves have stressed this. Good theories make surprising, correct predictions. That's boldness.
Is there a link between boldness and structural relevance? Seems like the boldest ideas might often come from the core.
Often, yes. Predictions that really diverge from the norm frequently tap into a theory's most unique, fundamental assumptions. It's hardcore, so they tend to be structurally relevant too.
But they aren't quite the same thing.
No, they're distinct. You could have a prediction that's quite peripheral, low structural relevance, but still very bold because it contradicts all other existing ideas about that peripheral phenomenon. Boldness compares the prediction to other theories and background knowledge. Structural relevance compares it to the rest of the theory itself.
Okay, crystal clear. So let's bring these three, novelty, structural relevance, and boldness, back to that first cogitate experiment. How does it stack up using this Lakatosian toolkit?
Well, if we assess the main predictions tested about location, posterior versus prefrontal, timing, sustained versus brief activity, and connectivity, local versus widespread. The paper argues they likely have novelty, both temporally, they weren't known facts, and in the use-novelty sense, the theories weren't built just to explain these specific patterns.
Okay, so novelty.check.
But structural relevance, probably lower. These predictions are about specific neural correlates, which likely require several bridging hypotheses to connect back to the core concepts of FIS, or global broadcast. They seem more like derivations in the protective belt.
So not directly testing the hardcore. And boldness.
Also probably limited. As we discussed, other theories could predict frontal involvement, and others could predict posterior sufficiency for certain states. The predictions weren't uniquely tied to either IIT or GNWT in a way that made the outcome incredibly surprising unless one of them was true.
So the Lakatosian analysis suggests the experiment, while valuable, might not have been the decisive test some hoped for because the predictions weren't maybe central enough or bold enough.
That seems to be the conclusion, yes.
Yeah.
It provided data, it spurred debate, but didn't land a killer blow, partly because of the nature of the predictions tested, viewed through this framework.
And critically, from a Lakatosian view, how did the researchers react?
That tells us about the research programs themselves, right? Absolutely crucial point. And what happened? Proponents on both sides, IIT and GNWT, didn't just accept defeat.
No.
No. They engaged with the results by questioning certain experimental limitations, suggesting alternative interpretations, and proposing modifications to their theories, mostly in that protective belt.
Adjusting the auxiliary hypotheses.
Exactly. Dehane, for GNWT, questioned if consciousness was really present for stimuli, not decoded frontally. IIT proponents questioned the spatial resolution of posterior measurements. This back and forth, this adaptation. Lakatos would see this as potentially progressive.
As long as it leads to new tests.
Yes, as long as these adjustments aren't just ad hoc fixes but actually generate new testable predictions. If they do that, then both IIT and GNWT are still functioning as evolving, developing research programs. They're learning from the encounter.
Interesting. So the lack of a clear winner doesn't mean failure, but rather ongoing scientific work. The paper also mentions Bayesianism briefly. How does Lakatos fit with that more mathematical way of looking at evidence?
It's an interesting connection. Bayesianism gives us formulas for updating how strongly we believe in a hypothesis based on new evidence. Lakatos' framework is more qualitative, historical, structural.
Okay.
You could try to formalize Lakatosian ideas like boldness or novelty using Bayesian maths. Some people are working on that.
Yeah.
But Lakatos adds this focus on the program, its structure, its long-term development, which isn't always the primary focus in standard Bayesian confirmation theory.
So they're complementary perspectives, maybe?
Perhaps, yeah. Lakatos emphasizes the dynamics over time and the internal structure of the scientific effort.
And finally, this Lakatosian view seems to chime with the idea that science is, well, a human, social process too.
Definitely. Lakatos saw scientific consensus emerging from a community process, influenced by shared standards and history. These adversarial collaborations are a perfect example. Scientists with different views agreeing on rules of engagement to test ideas.
It's cooperative competition?
Exactly. By participating, they implicitly endorse the Lakatosian idea that empirical testing, even if it forces adjustments rather than elimination, is how the field moves forward. It's a social commitment to method.
Okay, so let's wrap this up. We've dug into how consciousness researchers are using these adversarial collaborations, these direct experimental tests.
A huge step for the field.
But interpreting the results isn't simple. Lakatos' philosophy, focusing on research programs, gives us a really useful way to think about it.
Yeah, emphasizing things like the novelty of predictions, especially use-novelty.
And the structural relevance, how close is the test to the theory's core?
And the boldness, does the prediction really stand out from the crowd?
And seeing how theories adapt and adjust their protective belts in response to evidence.
Right. It suggests the main outcome often isn't instant elimination, but what the paper calls theoretical self-improvement. The theories get refined, sharpened by the experimental contact.
A process of evolution rather than revolution, maybe. Okay, here's a final thought for you, the listener, to mull over. This Lakatosian picture of scientific progress focused on adaptation, refinement, the survival of programs that learn and predict, how might that apply beyond science?
Interesting question.
Think about other complex areas or even your own strongly held beliefs. When you encounter challenging information, what does it take for evidence to feel truly compelling? How do you personally navigate that line between sticking with a familiar idea and adapting or embracing something new?
It's about how we all handle evidence and update our own research programs, isn't it?
Exactly. Something to think about. Thanks for diving deep with us today.